Force analysis on V engine. This is V engine. Now I will tell you that this is the one piston cylinder mechanism, and this is the line of stroke of this, and this is the line of stroke of this engine P, and this is Q. Okay, now please try to do the figure fast. Okay, this is F1, this is F1 H, means H means horizontal, this is F1 vertical, this angle is alpha by 2, this angle is also alpha by 2, this is alpha by 2, this is alpha by 2, this is actually, this one is the crank. Okay, crank has shifted from this vertical with an angle theta. Okay, so this angle will be equal to this one, this angle will be equal to theta minus alpha by 2, this angle. And okay, now please draw the figure nicely. This is X, this is Y. Okay, and this is a crank. This is the connecting rod of cylinder Q, and this is the connecting rod for cylinder P. Okay, similarly this is the force F2, this is horizontal F2H, this is the vertical F2V, vertical, horizontal, vertical. Okay, this is also horizontal, this is vertical. Okay, see the direction, this horizontal is in this direction, this horizontal is in this direction, these verticals are in the same direction. Okay, so let me read it. Primary connecting rods AP and AQ are operated by a common crank OA. The crank has moved through an angle theta from YY dash axis. Let W is equal to weight of reciprocating masses of each cylinder. R is the radius of the crank. Omega is equal to angular speed of the crank. Then the primary force on the piston P along OP is equal to nothing but F1, which I have shown you. P stands for primary force, primary, F1. 1 is the P cylinder. So W by G into omega square R cos theta minus alpha by 2. Okay, this is the primary for cos term comes, and this is the angle from the YY. This is the angle from the line of stroke of P of the crank OA. So the primary force on the piston Q along OQ will be equal to same way. This is the primary F2. W, we have taken the two cylinders, reciprocating masses are same. W by G into omega square R. Omega is also same because it is for the crank. So W by G into omega square R cos theta plus alpha by 2. So net primary force along OX, this F1H minus F2H. I have shown him this is in the negative x direction, this is in the positive x direction. So now, so force in the x direction primary is equal to this one. Okay. So this is equal to F1, we put it from here F1 and F2. So this is like this. Sin alpha by 2 is taken common from both the sides. So this is cos theta minus alpha by 2 minus cos theta plus alpha by 2. Okay. Now this is equal to, if you do this one, you will get 2W by G is equal to omega square R into sin theta into sin square alpha by 2. If you expand this 2, you will get it. Now net force primary along OY is equal to this vertical forces are additive in y direction, positive y direction, F1V plus F2V. So in the same way, Fy force in the y direction is equal to in the primary forces. Okay. So F1 cos alpha by 2 plus F2 cos alpha by 2. So this will be F1 W by G omega square R cos alpha by 2 is taken common from both the side. This is cos theta minus alpha by 2 plus cos theta plus alpha by 2. After expanding, you will get in the same manner F in the y direction, 2W by G into omega square R into cos theta into cos square alpha by 2. Okay. Okay. Now, if the V engine alpha is equal to 90 degree in general, it may be any angle, but this is 90 degree practically. Fx in the x direction primary forces W by G into omega square sin theta for 90 degree, and Fy is equal to W by G into omega square cos theta. So the resultant force primary for alpha is equal to 90 degree. This is okay. Now, thus the primary force can be completely balanced by a weight WB at a suitable radius B opposite to the crank such that WR is equal to WBP in the previously. Now this is the for primary, this is for the secondary forces. S stands for secondary. In the x direction, secondary is this one, w by g into n omega square r sin alpha by 2 into cos 2. This angle will be twice, no? Cos 2 this minus 2 of this, okay, is equal to 2 w by g into n. N is equal to here L by r, omega square r into sin 2 theta sin alpha into sin alpha by 2. So this is equal to, similarly fy, this is fx, fy in the secondary 2w by gn omega square r cos 2 theta cos alpha into cos alpha by 2. Now this is the analysis for V engine, the force analysis, primary force and secondary force. And okay, now here is a problem for V engine. Determine the maximum and minimum values of the resultant primary and secondary forces and the corresponding crank angle theta with the vertical for a 60-degree V twin engine. Twin engine means 2-cylinder. The following particulars are given. Now this is weight of each piston 1.2 kg, stroke 10 centimeter, connecting rod length 25 centimeter, the speed RPM 2000 RPM. Okay, now I will roll over the, this is just an application of the theory. I will show you the solution. P means primary. This is the formula we have derived. Okay, this is the value we are putting. So this is equal to Fy primary okay. Now the resultant okay, okay, that equal to okay, okay. Now for maximum resultant primary with respect to theta is equal to 0, this comes to this. So sin theta cos theta is equal to 0. That gives the theta value m pi. Theta is equal to twice m plus 1 pi by 2. M is equal to 0. Put m is equal to 0. You get theta value. M is equal to 0. You will get these two values. Okay. You put you put it RP max is one will give max and another will give minimum. Okay, this will be the maximum and this will be the minimum. Now if you want to find out the forces in Newton, I have already repeated, multiply by G. Okay, now for the secondary, I have done it one resultant secondary directly, just squaring and adding. Okay, this value have come from alpha is equal to 60 degree. This is this one and this one is same. So for that, this is root 3 by 2 W by Gn into omega square R, that we calculate. This is 46.5 kg. Okay, that is the secondary resultant force. Okay, okay.